Hey everyone, Morgan here. So we're going to start talking about titration, which is a huge part of this unit. There's going to be a lot of videos that I'm going to ask you to watch in addition to what we do as part of the normal lecture. So this is just a little bit of background here, just to gear you up for the rest of the things that we're going to be looking at. And a few terms: titrant, analyte, and burette. So in a typical titration, you've got your ring stand, you've got an Erlenmeyer flask down here, and then there is a burette that's going to be hanging off of the ring stand. That's the burette. Okay, so what is the titrant? The titrant is what you titrate with. It is in the burette, and most importantly, it is a known solution. We will know its concentration to a great deal of precision. The analyte is what you titrate, what you are titrating. It is an unknown, okay, and it'll be down in the flask. The burette, we'll just define it as an expensive piece of equipment. B-I-E-C-E, let's do that again. Now, what's really important about the burette is that it is good to 0.01 milliliters. Okay, it's a very precise lab tool. Now, graphs. This is really important. What does a titration curve look like for a strong acid, strong base titration? All of these plots will have pH on the y-axis and the volume added on the x-axis. This is basically what a strong acid, strong base titration looks like, with an equivalence point at 7. The pH starts low because the strong acid is in the Erlenmeyer flask. The strong base is in the burette, that's what we're titrating with, and it levels off here at the top when we've consumed all of the acid and we just have an excess of base contributing to the pH. So strong base, strong acid is going to look the same but inverted with the equivalence point at 7. Now, weak acid, strong base, what's going to happen is it'll still start low because it's an acid in the flask. It'll pop up and then it will buffer for a little bit and then shoot up like that. And the equivalence point is going to be basic this time. And there will be something here, which some people call the half equivalence point or the midpoint. Okay. And the pH is equal to the pKa at the midpoint. And we'll do the same, pH volume, we'll do the same thing here. Again, inverted. All right. So this time the equivalence point is acidic. So the equivalence point is when the moles of acid equal the moles of base. In Britain, it would be called the stoichiometric point. Okay, it's basically when the titration has determined the number of moles present. Then when you do one more drop, just one drop past the equivalence point, we get to what is called the end point. And a lot of people say that there's no difference between them, but no, one drop is significant in a titration. And that's when the indicator is going to change color and tell us, hey, you're done. You won't actually know when you hit the equivalence point. You'll know when you hit the end point because your indicator will change. So the midpoint. I was taught name midpoint. Halfway point's the British term. Half equivalence point is popping up now in a lot of books. And I've actually seen it on the AP exam. Like we said, the pH is equal to the pKa, and it's when we are halfway to equivalence. All right, we're going to keep on with these ideas over the next several pages. Thanks for tuning in. This is Morgan signing off.